Is Karma good enough for my projects? Speed, performance, quality. How does Karma hold up against other engines like Redshift, Arnold, or even Blender's Cycles? I had the same questions about Karma. Yes, we do save on cost because it comes shipped with Houdini and it feels like a bonus, but is it worth the effort to use? The truth is, Karma is very, very good. It's not the fastest engine out there, but it is very fast. The learning curve is very minimal because Karma's workflow is very Houdini-like. We're all here for Houdini. We know the basics of the node system. Karma's not that far off. And because Karma is so integrated inside of Houdini, this gives us a huge advantage since we can access all the rich attributes that are flooding our scenes from the simulations or procedurally generated geometry from the .NET, SOPNet, or anything. Volumetrics. Setting up fog in Karma. Let's get into some of that fun volumetrics in Karma, adding those fancy halo lighting into the scene to drive mood and atmosphere. Volumetrics can level up almost any type of scene in your renders. Here in this scene, I removed a bunch of nodes that imports the character into the scene just because I want to focus on the volumetrics just for a moment. I'm going to enable the texture materials that I had initially set up, and let's begin by adding a series of spotlights that's shining into the windows of this hallway on the right. Now I also have a dome light that's set up over here, but I'm gonna disable that so we can focus on the spotlights only. You can see that the spotlights are shining through these windows right here, so I'm gonna take a peek. This is where all the spotlights are. They're shining right into the hallway down here. So the lights are going through these windows. I cranked this spotlight up really, really large, just so that I can exaggerate the lighting and you can see where it's coming from. Now I'm going to turn this back down once we add the fog box and the volumetrics. So there's no volumetrics in the scene at the moment, but that's about to change once we add the fog box. Karma has this handy fog box in Solaris that you can drop into your scene. It'll create an area of fog or smoke or something for the light to bounce off of, so you can see those fancy halo lightings. So right now we don't see those streaks of light. Like, you see lighting coming through and bouncing off the surfaces, but you don't actually see the lighting in the atmosphere. So I'm gonna turn off Karma just for a second, just because the fog box does start to get a little CPU intensive or GPU intensive. So I'm gonna have it all set up first, and then I'll re-enable the Karma. In Solaris, type in fog, you'll get Karma's fog box. Drop this in, and it's literally a box. So you're gonna have to tell Houdini where you want to position the fog box. Let's get it up here. It'll place it in the origin right here. So it's this little tiny box right here. Select the fog box, hover your mouse over the viewport and press enter, and you'll have your usual box controls. And I want this to cover the entire hallway, but no more than only the hallway, because that's the only part that's in the shot. So the fog box does take up computing power, so you don't want to over cover your scene. You only want to cover whatever you need, that's whatever's in the shot. And it doesn't have to be exact. As long as you have whatever's in your shot, you have that covered, it's fine. Okay, let me enable Karma. Now, I had cranked up the spotlights to a ridiculous amount, so I'm going to have to turn it back down because you can't see anything right now. We still can't see much because the fog is too dense. It's just blanketing over the entire scene with thick fog. We'll need to tweak the parameters in the fog box to get the look that we want. So the density is a little high. I'm gonna put something 0.001. Oops. 0.001. Okay, that's too light. 0.01. Okay, now you're starting to see those lines. These lines. You can see where the lighting is coming from. BSDF Materials, creating something out of this world. So there is a MTLX surface. This has a BSDF. The MTLX surface node is designed for BSDF material shaders. Now, BSDF shaders allow you to create your own custom shaders from bottom up. It describes the surface of a material, how it absorbs light, reflects light, or even refracts light if you're doing glass-like materials. There are many different types of BSDF, each describing a different behavior of the surface, and we can actually layer the different types of BSDF nodes to create a whole new material that doesn't exist. This allows for a lot of flexibility. Now, BSDF nodes are different from MTLX standard surface material node. The standard surface is a physically based material, very much like the principal shader, which has everything ready to go, and all you have to do is tweak the parameters either manually on the sliders or use texture maps that I've shown with the Pillars 2 material. Now, be aware that I created a Karma material builder. Whatever material builder that you create in here as a subnetwork will limit your options of nodes inside the network. Karma Material Builder is compatible with MTLX nodes. So this one and this one are almost identical, but the MTLX builder here, it does not have the Karma nodes. So if I go like here, Karma, nothing comes up when I type in Karma inside of MTLX Material Builder subnetwork. And what are those Karma nodes? Karma nodes are a Houdini thing, nodes designed by sidefx to extend the functionality of MTLX. So what do I mean by that? MTLX nodes are inside of Houdini. Doesn't that mean sidefx created those? Not exactly. MTLX is an open source material library made by ILM in 2012, and several companies, including sidefx, has been contributing to this material library over the years, making it better. Because of its open source model, it allows many different 3D applications to be able to adapt to it easily and making it cross-compatible. So we can port our USD geometry with materials to another rendering engine without the need to recreate all the setup. Sounds magical. MTLX still has a lot of things that would be on the nice to have list, and sidefx realizes this. So they created a few Karma nodes to fill in the functionality gap. But since these Karma nodes are only a Houdini thing, it's not part of MTLX. And once you start using these Karma nodes in your material, you lose the cross compatibility with other 3D apps because it's only a Houdini thing. Let's create a BSDF material. And this is where you can create materials that wouldn't exist in real life. Because we're defining the lighting rules using BSDF nodes, MTLX surface materials, they're physically based materials, PBR, and they replicate how the lighting behaves in real life, how realistic lighting bounces on the surface of geometry in real life. But BSDF materials gives you more control. It is very different from the MTLX surface material nodes because all the hard work is done for you, obeying the real world lighting rules. Here, I'm going to start layering multiple BSDF nodes to create something bizarre. You wouldn't see this in real life, or you wouldn't find this sort of lighting conditions in real life. Here is a Karma material. So all I did was Karma Material Builder, and I've hooked it up to this shader ball. So we can just dive in. So we don't need this guy. We do need is MTLX surface. Now all the BSDF nodes are going to be hooked up to this guy. So let's put this down, and I'm going to hook this up to replace this. Let's just delete that and replace it. Now this is not a BSDF node. Now let's just put down a BSDF diffuse. Where are you? Okay, this diffuse right here. And let's just hook it up. It goes, now you can just match the colors. You can see this is the out, it's yellow, and it goes into the BSDF. One thing to note that I've noticed, BSDF nodes do not work with XPU. So if I change this to XPU, nothing will happen. If I change it to CPU, give it a second. Okay, let's change the color. Let's change the color to red. Or maybe, yeah, let's just do red. This is really bright red. So let's do that again. Let's go to XPU. Nothing. So it's XPU doesn't seem like it likes BSDF. Just keep that in mind. And I don't have any lighting for this scene. So let's go back to the lop. Now let me put the render flake on the dome light. Okay, now we have nice lighting. So the dome light here, Now I actually have an HDR map on here. With working with BSDF nodes, I find it's much better to have a HDR light map in your scene. That gives you the best preview. Now remember, BSDF materials, we're building everything from scratch. We don't have that luxury of the MTLX surface nodes, surface material nodes, where it's already made. Everything's already there. So let me remove this for you and you can take a look at what it looks like. It looks flat. Just so that you know, it's best, I find it best to load in an HDR map into your scene for BSDF. So let's go back into the material library while we have the render flag on the dome light so that it's rendering with the HDR light map. Now let's go in here and let's start tweaking this. This is just the diffuse. This diffuse material node gives you a soft, evenly distributed light reflection spread on the surface of the material. That's not very interesting. With BSDF nodes, you can actually stack them on top of each other and mix them together as well. So let me put down a dielectric. A dielectric material basically means non-metal material, like plastic or things like that, like non-metal. So let's just hook this one up and see what it looks like first. Okay. It looks very plasticky. Now I want them both. What we can do is MTLX layer. We can actually layer them on top of each other. So I'm going to put the dielectric on top and the diffuse on the bottom, and let's hook this up over here. That looks much better. That looks very fancy. Now with dielectric, we can actually choose how we want it to look. Do we want to tweak the reflection? So right now, scatter mode stands for reflection. So this is defining how it reflects. Well, we're tinting it. We're tinting it with white. What happens if I want the reflection to have something totally different? I want it to reflect blue. So let me choose blue. I don't see much. Let's start tweaking the IOR. To increase the IOR, and we're really tweaking how much is being reflected. And all the reflection is actually blue. In real life, this doesn't really happen. You reflect whatever your environment lighting gives you. This, you can actually define the reflection. So this behaves a little different. It's not PBR. This is not real world. This can give you the power to really configure your materials. Now there's something else we can do with this as well. Now here there's reflection, but there's also transmission. Transmission is more like the translucency or transparency. Now here it's a little harder to see just because we have two BSDFs layered. So let me just bypass that one and just hook the dielectric, which is where the transmission is coming from. And I want to see the transparency. And then for the IOR, I'm going to go back to normal, revert back to defaults. Now we got something more glass-like. You can start to see that there's these little round things that are embedded in this shader ball. So if we let's change it back to reflection. We don't actually see that. That's underneath. Let's go back to transmission and you can see it. It's there. These little knobs or holes, I'm not sure what they are, but they're underneath. They're embedded inside. And just because we gave it some transparency, using the dielectric BSDF, we can actually see it. Now let me hook this back up. And I'm gonna change it back to reflection. Because I like that. This looks sweet. This looks really nice. Now let's take this even further and we can actually mix some of these together. So instead of the layer, let me put down an MTLX mix node. And let me hook up the dielectric and diffuse, and then let's see what this looks like. That looks really flat. So let's go here and let's have a little fun. Let's experiment. Let's try layering two dielectrics. So I'm going to take this dielectric, move it over here. I'm going to put the inputs over here so it's not getting in the way. Make a copy of that and then MTLX layer. And I want to layer these two together. Let's see what this gives us. This is dark. Okay. So the one on the top will have a bit more roughness. And the one on the bottom, I'm going to give it a different color. Let's give it, there we go. Start playing around with this. What if I wanted transmission? Oh, that really, really spreads it out. I'm just playing around with this. And I'm going to feed this into the top now, replacing what we already had before. And then I'm going to take the original layer and feed it in. So now we have a bit of translucency. We have the dielectric defining how much it reflects. And the diffuse is more like the base material. This one, let's give it some other color for the base. Let's give it something green. Let's see if we can make it show up. Or let's see, purple. Okay, the other one is way too powerful. It's we can't really see the diffuse anymore. So what we can do a mix. MTLX mix. Take this, and then now let's put it down. So we don't want this anymore. Take this one over here. Now the mix is set to 0, so it's only showing the background. Go up a bit. Okay, now we're starting to see a bit of the dielectric. So this looks really nice. Well, it looks bizarre. So this is, one is completely showing this. So this is 1. And if I go 0, it is showing only the diffuse. Now I'm going to put 0.5, a bit of both. So you can start to see the reflection is peeping out. It's reflecting something. This one, you can start to see those little knobs there that's starting to peep out just because we gave it a bit of transmission. It's translucency. So you can have a lot of fun with this. PBR, texture-driven materials. Texture-driven materials is probably the one I use the most for almost all my projects. I would model my geometry in Houdini, then port it into Substance Painter to create my textures. Then to complete the workflow, I would bring it all back into Houdini and set up the Karma materials for rendering. If you buy an asset online and you want to bring it into Houdini to render it in Karma, you would still need to set up the same texture-driven materials using the provided textures that came with your asset. The process is the same, except you can skip the painter step. Usually if you buy a ready-made asset online, it would come with textures, but if it doesn't, it probably means the creator didn't even bother creating UVs for it either. If that's the case, you'll have to create the UVs either in Houdini or some other 3D app. I'm actually working on a procedural UV video for Houdini, that's still in the works, and a Substance Painter video for texturing. That will hopefully be released soon. This video will focus mainly on Karma materials and how to set up basic materials, procedural materials, and how to get grunge maps to level up your realism in Karma renders, and everyone's favorite, volumetrics. The textures I usually work with the most are PBR textures, your standard color, roughness, metallic, normal, and height maps. I'm going to use this hallway castle interior scene that I created in Houdini. This whole scene is 99% texture driven. The geometry is as low poly as I could ever make it because I wanted to show you the power of using textures to drive materials in your renders. I want to show you how minimal the geometry really is and what a difference it looks like with textures applied in Karma. You can see that the walls, there's very minimum geometry. Take out the grid. Okay, other than the holes that you see that I've punched in here and that halo lighting, the fancy halo lighting with volumetrics and the fog box, so that's why the windows are here. But other than that, you can see that the ground, it's just one piece of grid. It's just one plane. And the walls are really flat. Like there's barely any topology on the walls other than the windows. Now the windows have a little bit more to it. Just because I needed the beveling here, bevel took up most of the topology, used up most of the points. The stairs, well, I call it stairs. It's just one step. And you can see that this is literally just two rectangular boxes. So the textures are driving the entire thing. This is as low poly as it gets. Karma logo here. Now let me go back into the Karma rendering. I used Substance to create all the texture images, and the best thing about Substance and its library is it's incredibly detailed. Their assets are scanned from real-life objects, well, most of them are, and the software is layer-based and very easy to use. I used my HDA to auto-generate the Karma materials and speed up my workflow. My HDA version 5 is going to be a new release and will be available for all the Perk members, but I want to demonstrate how you can do this manually so you know what's going on under the hood. So we're going to set up one of these materials. I'm not going to show you everything because they're all the same. Once you know how to set up one of them, you know how to set up all of them. The pillar material, that's the material that's driving all these pillars in the castle. Now it's a little dark in this one just because of the fog box and all the volumetrics going on here. I'm going to turn off a bunch of lights and isolate just the pillars on the wall. This is what the pillars on the side wall looks like without my fancy texture materials applied. And notice the difference once I enable the materials. Ignore these guys, and that should isolate the pillars. Okay, look under the hood inside the material library, which is where all the materials are living in. They're all the same. So this is the pillar material. You have your base, roughness, metal, normal, and height. Let's go back. This is the walls. Let's organize this a bit. And you have the same base, roughness, metal, normal, height. The reason why I have all the walls separate into each of its own material is because they're actually, the texture is very different. It was much easier to work with in Substance Painter, having a different material for the floor, different material for the walls. You don't have to do this. Like, you can have a mask in Substance Painter and isolate each wall. Or I was being lazy, I just create a different material slot for each wall. This way I could easily work in Substance Painter by clicking and dragging my layers onto each material slot for each back wall, side wall, and floor. But if you look under the hood, they're all the same. Now we're going to create a karma material. So we're going to recreate that pillar material. Pillars 2. Assign material node that the castle pillars geometry is assigned the materials pillars. Now the castle pillars Solaris primitive name. Now this is something that was discussed in the previous Solaris video, but I'm just going to quickly go over it so you don't get lost. And let's take a look over here in the scene tree graph. Everything organized well in this format. This comes from the name geometry. Let me just go back up to the SOP level into the castle interior. So this is where the name attribute is created. And what this looks like, let me open up a geometry spreadsheet. So in here we have the name attribute of the primitive type. And it's actually identical to the SOP material path, which is the material slots, just because that's what I'm duplicating into the name attribute. These name slots is what Solaris will be picking up, and that's going to define our pieces, our parts pulled by Solaris. That's what Solaris recognizes. So if we go into the LOPNet, this SOP import, the scene graph, and these are the identical names of what I have as the name attribute. Taking advantage of the fact that Solaris recognizes the name attribute from SOPs, we can organize our geometry into parts, which makes it easier to assign materials and manipulate the mesh in Solaris. So once you have this organization and you have your materials created, and then you're here assigning it, you can select your material library in Solaris, and then come over to your scene graph. You can see that Pillars 2 is not recognized over here. That's because in the material library, you actually have to add it to this list. You can see that it's not on the list. Click this little button and it'll add a slot on the bottom. So if I scroll all the way down, material VOP. On the material library node itself, you can actually assign the material directly to the geometry as well. But I want to do it in 2 separate steps. That way it's easier for you to understand. That's the purpose of this geometry path. But what I really wanted to show you is I want my Pillars 2 to show up in here in this list. So right now Pillars 2 is not on the list. Only Pillars 1, just because I had that before. I had that working. Tell Houdini that it exists. And you can see it will appear. And what we're going to do is click this and drag it to pillars. That's the mesh component. So that's our geometry. And you can see that it'll automatically create a new assigned material node for us. Okay, let me zoom out. Let's take a look at this guy. And you can see that it pillars and Pillars 2. Turn on Solaris and let's see what it looks like. Basically nothing, because our Pillars 2 it's a brand new material. It's an empty material. So let's go back into the material library and finish that Pillars 2. This is what we're working with. This is what Houdini gives you by default when creating a Karma Material Builder subnetwork. It's like a template. And 90% of the time, this is all the nodes that you'll ever need. In the BSDF section of this video, you learn that the BSDF material nodes replace this MTLX standard surface node. But let's focus on this MTLX standard surface for now. Just going to drag the displacement and material properties down so we have more real estate. I'm going to expand the base. Specular. Okay, and there's inputs, but we're not going to use this. So I'm going to put this over here so it's not in the way. Now what we need to do is pull in our texture images. If you bought an asset online, it'll come with textures or it won't, or you can create your own textures. Now, these are the textures that I have available for my pillars. For those of you with a sharp eye may notice these rat files. These get generated by Houdini after Karma compiles the shaders for the first time. My only guess is that these are part of Karma's optimization process because the rendering does speed up after the first time after Houdini is done compiling your materials. The ones that we're more concerned about are these ones, these PNG files. To load these PNG files, we need MTLX tiled image, or you can just go MTLX image. If you have a tiled repeating image, you might want to use this. So the tiled image would be useful for grunge maps and scratches and stuff, which is something I'm going to go over in just a bit. The only difference between the MTLX image and tiled image nodes is the repetition. For this pillar's material, my textures aren't repeating, just because they were custom made in Painter for this particular geometry. Usually you'll have tiled images for grunge maps or scratch textures. I can still use the tiled image node for this pillar's material and just set it to non-repeating or one tile, which is non-repeating. This is going to be the base color. Some texture images may have an alpha channel for the transparency, for example, hair or skin. Given that the image is a PNG or EXR, something that supports a fourth alpha channel. If you have a JPEG, that physically doesn't support a fourth alpha channel. So if you're creating your own textures, you need to watch out for that. Choose color 4 to support the forest alpha channel if you need one. Now click this and I'm going to find my... Now this is the one I want. So let's just pick the base color PNG. Now let's hook this up to the base color here. Don't get confused on the first base input. This base over here tells how much to multiply, how much weight do you want to put on the base color. If you choose 0, so you can see that our image is loaded right away. It doesn't look like much because we don't have roughness, we don't have specular, we don't have any of the good stuff. But let's see what happens if I put 0. It's nothing. You know, we lose it all just because the weight is down to 0. Now I want to see something, so I want the full color. So I want 1. Now let's create another tiled image and let's load in our roughness. Roughness PNG over here, and this is going to be hooked over to specular roughness, and I want to hook it over to diffuse roughness. I'm going to do this again. Metallic. Click this, find the metallic over here, and metal over there. I'm going to do this one more time, 2 more times. One for the normal map. This one is a little bit different. The normal map looks like this. This doesn't look normal at all. The normal map is storing vector data, directional data of where the normals of the polygons are facing. In an image file, we have RGB that makes up the image. Those are our primary colors. Is taking those 3 values and sticking numbers in them and just using those spots, using the image to store data, vector data. And this tells Houdini what the normals, the surface of our texture. If there's a concave or convex, or if it's curved, or there's a hole in the middle, or there's trim sheets, the details of the surface. So we can't really load it in the same way. I mean, we can use the same tiled image. For the color file space, we want the raw. These are color spaces, which goes into a whole different topic. But what you need to know if you generally work with texture images generated in Substance Painter or any other 3D software, you'll have the choice of choosing what color space you want to generate. If you're not sure, you can just toggle around them, sort of eyeball it. That's the quickest way to do it. It's not the most accurate way. To know precisely what you have created, you have to go back to the software that you generated the texture images with. Now, if you bought something online, generally they'll tell you, the creator should tell you, or you could just message them and ask them. But for the normal maps, it's going to be raw. There is no color space. We don't care about the color. We actually care about the data that's in it. It's just using the color slots to store actual physical number. So we want, for the normal map, we want raw. Then we have to throw in MTLX normal map to actually convert it. So that goes into in, and you can see here that it's using the tangent space. Now we're gonna hook this into normals over here. Now let me just disconnect this just a bit so you can see what it looks like. So it looks really flat right now. But once we hook this up, there you go. See, there's a bit of bump. And we have our displacement. Height PNG, okay. Now this goes directly into the MTL displacement. But it should be hooked up to displacement. And you can see that we get displacement right away. But it's huge right now. That bump should not be that much. Like this should not look like that. So let's change the scale and reduce it to 0.1. And there's one thing I forgot is in the normal, we don't want a color 4. We want a vector 4. Oh, sorry, vector 3. Vector 3. Just because it's actual physical number data that we want. So this will give us the accurate values coming from the normal map. Now we're still getting that disconnect. I'm not sure why this artifact was happening, but all I had to do was turn off Karma and turn it back on to fix it. Well, that's about it. That's all you have to do to finish off the material. Now you're going to have to do the same PBR textures and connect it to your shader, the shader of your choice. Now the MTLX standard surface shader, it's my go-to shader. Thanks for watching and sticking to the end.